Okay, so let's start with this week's tutorial. This week's tutorial is basically based on theory, so most of the things you'll need to go over is in terms of its meaning and its explanations, right? First question is, what is serial input output? Where would you use serial communication? So serial input output is basically where you basically the serial communication is basically where when a series of bits or data is transmitted in series, right? So one at a time, it is transmitted in series. So serial communication enables a microcontroller to be connected to another microcontroller to a PC using a serial cable, right? Some microcontrollers have built-in hardware called USART, right? That is universal synchronous asynchronous receiver transmitter to implement a serial communication interface, right? The baud rate and the data format can usually be selected by the user program. If any serial input-output hardware is not provided, it is easy to develop software to implement serial data communication using any input-output pin of a microcontroller. So serial communication is overall, I would say that serial communication is basically um, basically communication between a processing unit and another processing unit. So you are basically sending information from one processing unit to the other processing unit. So you'll need a serial communication in that particular case because you are sending information in series, right? Bits in streams. So you have only one stream of line to transmit bits from one microcontroller to another microcontroller, or from one PC to another microcontroller, right? So basically, whenever you need to transfer data from one unit to another, you'll need serial communication. So like it says, if serial communication hardware part is not present, you can implement the same serial communication using the input output pin of a microcontroller using software as well, right? Question number 2, what is the difference between synchronous and asynchronous transmission? So synchronous transmission means the term synchronous itself means two things are in sync, or things are working together, right? Or communicating at a same frequency or same timing, right? So when we are dealing with timing or frequency, basically we are referring to clock. So when a system is synchronous, basically it means that it is using the same clock or timing at both the ends, right? So synchronous, the definition itself defines what asynchronous transmission is, right? So synchronous means agreed timing for sending of ones and zeros, right? Basically bit transmission at a agreed time. The transmit and receiver sides of the communication circuit have both boarded to communicate, right, or synchronize their signal, and have agreed just what a digital bit encoded into this signal looks like. Synchronous systems negotiate the communication parameters at the data link layer before communication begins, right? While asynchronous is basically when both the sides are working at different frequencies, or both the sides are not having the same clock, right? When they are transmitting the data from one end to the other, right? So basically, that is the same definition given over here. It is basically the opposite of synchronous. Communication utilizes a transmitter and a receiver and a wire without coordination about the timing of individual bits. There is no coordination between two endpoints on just how long the transmitter leaves the signal at a certain level to represent a single digital bit, right? So there is no timing of what time the bit is transmitted from the transmitter and what time it is received at the receiver end. So it is working at different timings, right? Each device uses a clock to measure out the length, right? This clock could be different, right, of different values. The transmitting device simply transmits. The receiving device has to look at the incoming signal and figure out what the receiving and what it is receiving and coordinate and retime its clock to match the incoming signal, right? Example is the RS232 communication, right? 3, what's the difference between bit rate and the baud rate? The bit rate is basically the number of bits per second that is being transmitted from the transmitting unit or the receiving unit, right? Whatever the transmitting or receiving unit is dealing with is the number of bits per second, right? So that is what is given over here. Serial data speed is usually stated in terms of bit rate. However, another oft-quoted measure of speed is baud rate, though the two aren't the same, right? The bit rate is basically the number of bits per second, right? It is the data rate. R is the function of the, so this is basically the formula given for calculating the number of bits per second, right? What is baud rate? Baud rate is basically the number of signal or symbol changes that occur per second. A symbol is one of several voltage, frequency, or phase changes, right? So basically, bit rate could be the number of bits being transmitted, right, in 1 second. Baud rate is number of changes that is happening in 1 second, right? So you can basically have, let me just give you a quick example. You have a signal, right? You have a signal and you're transmitting, let's say you're transmitting 0, 0, and then you're transmitting 1, 1, right? So basically you're transmitting 1, 1, 0, and 0 in 1 second, right? So basically the bit rate of this particular signal is 4, right? 1, 2, 3, 4, 4 bits per second, while the baud rate of this is 2 baud per second, right? Because you have two signal changes, one signal change, and this is the second signal change. So basically the baud rate and the bit rate are not necessarily the same, right? It can be different because baud rate is the number of symbol or signal changes that occur in 1 second, while the bit rate is the number of bits that is being sent out or received per second, right? So you can see that we have 4 bits per second in this particular signal, but the baud rate is 2 bauds per second, right? This is just one example, right? Anyways, let's move on. So that was the difference between baud rate and bit rate, right? There's rest of the parts that is explained over here. You can just go over it. Next is what is the concept of simplex, half duplex, and full duplex communication, right? These are 3 modes of channel operation. So what are the differences between these 3? Simplex is basically the signal is being transmitted one way, right? It is just basically a one-way traffic. So let's say we have a transmitting end, we have a receiving end, right? These blue lines are transmitting and receiving end. And what happens is that we are sending out signal, right? Let's say we are sending out signal. Let's say this is my transmitting end, TX. This is my receiving end, right? In a simplex system, it is data in a simplex system is always one way, right? It is basically you are sending data from the transmitting end to the receiving end. So one-way traffic, right? There's no other way. So you are only transmitting from one end, you are receiving at one end, right? There's no other transmission from the receiving end to the transmitting end, right? So there's only one-way traffic, right? In this particular case. So simplex channels are not often used because it is not possible to send back error or control signals to the transmitting end. So basically in a simplex system, you only send data to the receiving end, right? Then we come to a half duplex side. Half duplex channel. So in a half duplex channel, you can send and receive data, but not at the same time. So what happens is you can use this one line, right? There is only one line in this particular system. Let's assume here is this particular arrow, right? Let's draw it again. So when we are dealing with a half duplex system, let's say this is a connection between the receiving end and the transmitting end. So you'll be able to send and receive the data one at a time, right? You can send the data from the receiving end to the to the transmitting end, or you can receive the data from the transmitting end at the receiving end, right? But it will be one at a time. You can either send the data from the receiving end to the transmitting end, or you can send the data from the transmitting end to the receiving end, right? So at both the ends, you can send and receive the data, but only one at a time. Some of the examples of these are the is the talkback radio, right? Some of the examples are the talkback radio or the CB radio. So you only can talk, right? While you cannot receive, I mean, you can only send and receive data one at a time, right? So in a talkback radio, you talk, but the other person won't be talking back to you, right? Once you finish talking, then the other person can respond to you. So one at a time, right? Communication happens one at a time. At a full duplex system, what happens is that you can send and receive the data at one time, right? It is simultaneous. Basically, you can send and receive the data together at the same time, right? So simplex, one-way traffic, half duplex, it is two-way traffic, but one at a time, right? Full duplex is sending data simultaneously, right? You can send and receive the data simultaneously, right? You don't need to wait to either send or receive, right? You can simultaneously send and receive the data at both the ends, right? Question number 4. Answer the following based on the PIC 18F87222 hardware features. So I use real-time clock. Like I said, real-time clock is basically dealing with the actual time and date of the I mean, it is the absolute time and the absolute date and the time information that is related to the programmer or whatever. Whenever we are using the real-time clock, right? It is basically relaying out the actual date time information using this particular feature, right? So real-time clock enables a microcontroller to have absolute date and time information continuously, but built-in real-time clocks are not common in most microcontrollers since they can easily be implemented by either using dedicated real-time clock chip or by writing a program. We have already discussed about this. The real-time clock, it is basically the time itself tells you that we are dealing with the actual date and time. So whenever we are using this particular module, we can basically extract the actual or the absolute date and the time information, right? This is not necessarily a feature that has to be built in. It can be also programmed or coded into a particular program, right? Current sync and source capabilities, like I have already said, current sync is basically the ability to withstand the amount of current, while current source capability is basically the amount of current it can source out, right, or give out. So basically, when we are dealing with the microcontroller, it is the amount of the kickback current that is being sent from the peripheral back to the microcontroller. The ability to withstand the current that is being delivered to the microcontroller. The current source capability is basically the capability of the microcontroller to give out or to source out the current that is required by the peripheral, right? C, the master synchronous serial port. So again, in this particular case, we are dealing with the serial communication port, right? In this particular case, the master, you might have come across the master slave configuration. So basically, this particular module gives the microcontroller the ability to act as a master or to program or give out instructions to other peripherals that is being connected to this, right? It acts as a controlling unit. So when we have connected, or when we are utilizing the MSSP module, basically we can use the microcontroller or that particular unit that has this MSSP port as the master configuration, right? So this is the controlling unit, while the other units will act as a slave unit, right? So there are some other definitions you can go over, but this is MSSP port. This is really important. This is a serial communication module, and the term master indicates that this module or this serial communication could be utilized so that the microcontroller could be the microcontroller could act as a master unit in a master-slave configuration, right? Okay, that's it for this week's tutorial. I have already sent out the solution. It is already available in your chat box, right? So please make sure you write it down and submit it in the Dropbox provided in the Moodle show, right? It is really compulsory for all of you guys to submit the solutions, right? So that's it for this week's tutorial.